Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. Reaction 1 analysis. The starting material is a 2-methoxy 1,3-dioxylane bearing a 2-hydroxyl chain. Under acid H+ conditions, the methoxy group at the acetyl carbon is protonated and leaves as methanol, generating a stabilized oxocarbenium ion, a cyclic carbocation stabilized by 2 oxygen atoms of the dioxylane ring. This is a classic SN1 type process. The leaving group, OMe, departs first to form a stable carbocation intermediate, then the pendant hydroxyl group attacks intramolecularly to form the bicyclic product, the epoxide-fused dioxylane. The oxocarbenium ion is tertiary acetyl stabilized, strongly favoring SN1. Therefore, reaction 1 proceeds via SN1. Reaction 2 analysis. The substrate is a butyrolactone with a carbon-bearing Br and 2 methyl groups, a neopentyl-like or tertiary-like center within the ring. However, despite the substitution, the carbon-bearing Br is inside a rigid 5-membered lactone ring. Azide, N3, is an excellent nucleophile. In this case, while the carbon is tertiary, the reaction with a good nucleophile like N3 in a lactone system proceeds via SN2 mechanism with inversion. The rigid ring constrains the geometry, and N3 is a strong enough nucleophile to displace Br directly. The product retains the lactone ring with N3 replacing Br. Therefore, reaction 2 proceeds via SN2. Why other options fail? A. SN1, reaction 2 is not SN1, N3 is a good nucleophile and the reaction is bimolecular. B. SN2, reaction 1 is not SN2, it proceeds through a stable oxocarbenium ion, SN1. D. SN1, reaction 1 is SN1, not SN2, and reaction 2 is SN2, not SN1. The combination SN1 for reaction 1 and SN2 for reaction 2 corresponds to option C. Therefore, the correct answer is C. Therefore, the correct answer is option C.